Hello everyone, we are Team ACE and this is the video report for our NLP project. My name is Tejashree and Sarah is my teammate. We now discuss the Ask Question Generator program. Naive sentence boundary detection algorithms will use punctuation marks to identify where the text must be split. This might result into a false boundary detection, and one whole sentence may get divided into more than one. We use the sent detect function of the sentence detector ME class in Apache OpenNLP to do this. The pre-trained English model EN sent bin is used for this purpose. For the ease of simplification, we select sentences which are less than or equal to the average value of the length of all the sentences. Ergo, we get shorter and prettier sentences on which questions can be generated. We have simplified the sentences by using the result of dependency parsing. We select the relations which contain NSUBJ for making shorter and simpler sentences out of longer ones. For example, in the dependency parse of this sentence, 4 NSUBJ relations can be found. The governor and dependent are used to find the other words that can make a complete sentence out of it. We stop adding words when the words we find are dependent on some other NSUBJ relation. These are the three simplified sentences which were derived out of the original sentence. We also get a grammatically incorrect simplification, which is Dempsey to quit due to his family's time and money constraints as his eldest sister was becoming a ranked youth tennis player. This is because of the relation NSUBJ, where Dempsey is the dependent of the governor, quit. The question asking system takes the simplified sentences as input and then generates yes or no questions and WH questions based on the inputs. Our QA system works in the following way. Whenever the system takes an input sentence, it goes through an NLP pipeline to obtain the different grammatical features of the sentences for further processing. The pipeline includes syntax tree parser, dependency tree parser, POS tagger, and named entity recognizer. For syntax tree parser, dependency tree parser, and POS tagger, we use the Stanford Core NLP package. For named entity recognizer, we use both Stanford NER and Apache OpenNLP. The reason for this is that the Stanford NER doesn't work well on recognizing person entity, especially when the person's name appears at the beginning of the sentence. For example, given the sentence, on May 2, 2006, Dempsey was named to the US roster for the 2006 World Cup in Germany. These are the results of using the different libraries. Next, the QA system begins to transform declarative sentences into questions. The process of transformation is decompose the main verb, invert the subject and auxiliary verb, identify the answer phrase, generate the question. In the phase of decomposing the main verb, first we identify if there is an auxiliary verb in the sentence. If not, we use the following rule on the syntax tree to extract the main verb in the sentence. Then we transform the verb to the base form and get the appropriate tense, which determines whether to use do, does, or did according to the tag of the main verb. We have made use of the morphology class in the Stanford NLP package to do this. In the phase of inverting the position of the subject and auxiliary verb, the main task is identifying the subject phrase of the sentence. Here we use the dependency tree to extract the subject phrase. We first take the dependent word of the NSUBJ relation in the dependency tree. This is the main word of the subject phrase, and then we get all the words that are dependent on this main word, which will now be the governor word for the compound, determiner, amod, and or dependent grammatical relations that we got from the dependency parse tree. These words together with the main word are the subject phrase. The answer to such a question could thus be either a single word or a phrase which is a set of words dependent on the main word. After getting the subject phrase, we check if the main word in the subject phrase is identified as a person or organization by performing named entity recognition, and then we keep a record of it for further steps. Next, we identified the answer phrase in the sentence on which the WH question would be framed. Note that for the yes-no question, this part is not needed. In our question answering system, there are 4 kinds of answer phrases: subject, object, location, date. Each of these corresponds to a certain kind of question. The steps for question generation for the subject phrase were explained in the previous step. For the object phrase, we tried to use the dependency tree at first. The rules were created as shown over here. However, we notice that when it comes to identifying object phrases, the dependency tree has a high error rate, especially under the second rule. Thus, we cannot trust the dependency tree in this case. In order to guarantee the quality of the questions, we decided to abandon the second rule and ask only questions on an object phrase when there are copula words. For the where questions, we extracted the prepositional phrases in the syntax tree with the location entity in it. We also add some other rules to deal with the corner cases here. For the when questions, we extracted the prepositional phrases with the date entity in it. To generate the question, we begin the sentence by writing the appropriate WH question word: who, what, when, where. Then we append the inverted sentence. Next, we delete the answer phrases according to the question word we are using. At last, we add the question mark, and there we have it. The question generation is done. As for the yes no question, we simply use the inverted sentence that was processed before and add the question mark at the end. The sentence simplification step and question generation step guarantees to give pretty good results overall. The only problem with the ranking is how can we pick up the best questions among all the results. We investigated and played around with several methods during the implementation. One possible way is analyzing every question with the syntax tree and comparing their score. However, we found out that the score function gives a value which is highly relative to the length of the sentence and is the score of the chosen parse tree. The questions our system generates are of various lengths. Thus, the score attribute is not applicable to our system. We also looked into Apache Lucene packages, which has the TF-IDF algorithm in it, but unfortunately, we were not able to dig much into it. In the end, we decided to rank our generated questions by length and output the top n longest questions. Coming to the answering part of our system, the first step is the same as the question generation system. We perform sentence boundary detection. The second step is to perform co-reference mapping and replace all pronouns, common nouns, and indirect references with the proper nouns. The third step is using named entity recognition to speed up candidate answer sentence search. The fourth step is to parse the question, extract the verbs, and derive their correct conjugates. The fifth step is to find the keywords and thus the candidate answer sentences. The last step is to parse the candidate answer sentence to get the concise and hopefully precise answer. This step pre-processes and creates a named entity hash map. The keys of this hash map are recognized entities such as person, location, organization, date, time, money, and percentage. This is done by using the class NameFinderMe of Apache OpenNLP for identifying persons and Stanford NER for recognizing the other entities. The list of sentences pertaining to these entities are the values for the corresponding keys. We club the date and time entities so that the when questions can be answered by looking at the list of the sentences under one category. The who and whom questions can be answered by considering the sentences in the person category only, and where questions can be answered by the ones in the location category. Which questions that are followed by common nouns that are indicative of an organization can be answered by checking the sentences in the organization category. For performing verb conjugation and getting the candidate sentence that might have the answer to the question, we extract the SQ clause from the question. The auxiliary and main verb of the questions are recognized so that the tense of the sentence can be identified. Then the base form of the main verb is converted to the appropriate tense by using WordNet so that this newly created verb can be used as a keyword. The noun phrases are used as keywords as well for answering the medium questions. Then string matching is performed to determine the candidate answer sentences. For answering the medium questions, once the appropriate sentence is chosen, this sentence is passed in a dependency tree. If it is a who question, the subject of the sentence is identified and all the relations such as compound, determiner, amod, and dependent are found so that the answer phrase can be reframed and displayed. This is done in the same way which was explained earlier in the question generation section. If the question is a yes-no question, then the given rules determine the answer. For questions like where and when, the prepositional phrases of the candidate answer sentences are checked and appropriate location, date or time entity is then chosen out of them. There can be nested prepositional phrases as well. Hence, we find the most appropriate and concise prepositional phrases that give us the required answer. This is done by making sure that the answer that is chosen from the prepositional phrase is not already present in the question. Please forgive all the imperfections in our project as we are a two-member team. Thank you, Dhanyavad, Shyasyani.